हेलो। लास्ट क्लास में मैंने डिस्कस किया था इलेक्ट्रिक फील्ड ऑन एक्सियल लाइन एंड टुडे I will discuss about electric field on equatorial line. So today's topic is electric field on equatorial line. So try to understand electric field on equatorial line. Remember, first of all, we have to know about what is equatorial line. A line perpendicular to the dipole length or electric dipole axis and passing through the midpoint of electric dipole. This line is called equatorial line. As for example, here, look at, this is an electric dipole with negative charge situated at point A and with positive charge at point B. And this O is the midpoint of AB. So we draw an imaginary line perpendicular to line AB. This perpendicular line gives you equatorial line. Now take an arbitrary point C on this equatorial line where electric field is to be determined, is to be calculated. And the things here you see here, plane, two-dimensional picture, this is called equatorial plane. O to C, an extended line beyond C, is equatorial line. And this is the equatorial plane. Now, try to understand, consider a point C at a distance r from the center of electric dipole O of the dipole on the equatorial plane as shown in the figure. So, in the same way as here is a system of two charges, in order to calculate electric field at a point in the space due to system of two charges or more than two charges, we apply principle, a superposition principle. In superposition, what we do, first of all, we consider one pair of charge, or we determine here electric field due to charge at B. Electric field due to charge at B. First of all, we determine electric field at point C due to electric charge at B. And say this electric field is denoted by E plus because it is due to positive charge. So we write here E plus and its direction will be in this direction because just I have told you that in order to test electric field at any point in the space, we have to take a unit positive charge or test charge, Q naught, just say Q naught. So when you place here Q naught, test charge is always positive. So electric field will repel this Q naught in this direction. Therefore, due to positive charge, electric field will be directed in this direction, E plus. Next thing, we have to find out electric field at point C due to negative charge minus Q at A. And this electric field will be directed because it is negative, so it will attract this test charge here. So it will be directed in this direction. Now we have two vectors. This electric field is denoted by minus E, E minus. So now we have two vectors, E plus and E minus. And hence their resultant vector will be in this direction. Okay, so now let us check out applying concept of resultant vector. Since the point C is equidistant from positive charge and negative charge, therefore magnitude of electric field at point C due to positive charge and due to negative charge will be same. Only their direction will be different due to their different nature of charge. But magnitude will remain same because they are separated from each charge with equal distance. And this A to O is equal to a small a, this is distance, and O to B is a small distance, a small a, this is the distance from the midpoint of dipole. And so try to understand the direction of electric field due to positive charge E plus is along BC. This will be directed along BC. Look at this is in this direction. Okay, and similarly, direction of electric field due to negative charge is directed along CA. Look at here, CA, C to A. And E plus, electric field E plus and electric field E minus are resolved into two components. One component parallel to the dipole axis and other component perpendicular to the dipole axis. So the perpendicular component E plus sine theta and E minus sine theta are oppositely directed, so cancel each other because of their same magnitude. So look at here. This is the point C, and this electric field is resolved. Positive component, one of the component of this electric field will be in this direction, say E plus sine theta. And electric field E minus will be directed in this direction, E minus sine theta. So as E plus and E minus has same magnitude, therefore these two components will cancel each other. Only this component will be add up together to give effective electric field. So effective electric field will be given in this direction. So next, the magnitude of total electric field at point C is the sum of parallel component of E plus and E minus, and the direction is along opposite of electric dipole moment minus P cap, where P cap is unit vector for electric dipole moment, and hence in the vector sense we can say that net electric field at point C is equal to sum of the two components. This is also negative and this is also negative. Why negative? So try to understand here. Both the components of horizontal components or parallel components of E plus and E minus are along negative x-axis. So we write here, this is negative and this is negative, so add up together. The magnitude E plus and E minus are the same and they are given by magnitude of electric field E plus and E minus is given as KQ upon R square. Here, look at figure. This distance B to C, this distance B to C is determined using Pythagoras theorem, root under A square plus R square. So this distance B to C will be root under R square plus A square. Also A to C, also root under R square plus A square. So now we see the distance of the point where electric field is to be determined due to charge at B is KQ upon R square. And we place here, instead of R, we place here root under A square plus R square. So look at here, this is the result here. Yeah. So magnitude of both the field is this one. KQ upon root under R square plus A square whole square. So root will be cancelled out. Now, so net electric field will be here, this one. Placing this value here, you place E plus and E minus there at this point, and you will get here. Mute your mobile. म्यूट करो अपने मोबाइल को. Okay. So total electric field at point C is given by 2q cos theta divided by r square plus a स्क्वायर, और इसको हम k कह देते हैं, पूरे को इसको k कहते हैं, और ये p यूनिट वेक्टर है, और नेगेटिव साइन इंडिकेट कर रहा है कि इलेक्ट्रिक फील्ड बी डायरेक्टेड फ्रॉम पॉजिटिव चार्ज टू नेगेटिव चार्ज, जबकि p का डायरेक्शन है फ्रॉम नेगेटिव टू पॉजिटिव, और ये होगा पॉजिटिव टू नेगेटिव. Total electric field will be directed from positive to negative, while electric dipole moment is directed from negative to positive. That's why ये सही है, exact है. Now next step will be there कि eliminate cos theta. So how can you eliminate cos theta? Look at you can eliminate cos theta from this example. This is the theta, and cos theta equal to base upon hypotenuse. So base is a and hypotenuse is root under r square plus a square. So when you eliminate cos theta from this expression, you will see, putting this value cos theta equal to a upon root under r square plus a square. Therefore 2aq are divided by r square plus a square into root under r square plus a square will be r square plus a square whole 3 upon 2. This is the result, and hence this is the value of cos theta. So we have put here, where here value of cos theta is placed here. So we get here this result now. So total electric field is obtained in this way, because you know well that 2a, 2 into a is dipole length, and dipole length into q equal to dipole moment. So we place here 2aq equal to vector p. So this is dipole moment, and now we have total electric field at very large distance. Just compare, if r is comparatively much greater than that of the a, then a can be neglected in comparison to r. So we have total electric field at equatorial point C is kp upon rq. Place this whole as k, then kp upon rq. Again we have got the here electric field is inversely proportional to cube of distance. In case of electric dipole at equatorial line, axial line, we have got electric field at any point on axial line is 2 kp upon rq, and here kp upon rq. So वहां पर होता था 2p upon 4 pi epsilon naught rq, और यहाँ पर हो रहा है p upon 4 pi epsilon naught rq. इसलिए अगर दोनों की रेशियो निकालने के लिए कहा जाए, total electric field at axial line and total electric field at equatorial line, where do we get maximum electric field? So we get electric field maximum in case of axial line, and electric field at equatorial line is just half of that of on axial line. Next, दूसरा तरीका से भी आप काम कर सकते हो. देखो, ये तो हमने रिजॉल्व करके बता दिया कि हम इलेक्ट्रिक फील्ड को दो कंपोनेंट में रिजॉल्व किए, एक कंपोनेंट इधर कैंसिल कर दिया तो एक दूसरे को. अब दूसरा कंपोनेंट है ये देखिए, दूसरा हम अप्लाई कर सकते हैं वेक्टर लॉ. रिजल्टेंट वेक्टर क्या होता है? वेक्टर ए प्लस वेक्टर बी इक्वल टू उसका मैग्नीट्यूड निकालें तो क्या हो गया? रूट अंडर ए स्क्वायर प्लस बी स्क्वायर प्लस 2ab cos थीटा. तो उससे भी आप निकाल सकते हैं. हेलो हेलो. हाँ, एक्चुअली मैं ऑनलाइन क्लास ले रहा हूँ, तो मैं कुछ देर के बाद बात करता हूँ. ठीक है? हाँ, मैं ही ले रहा हूँ. ठीक है? Hello. Yes. So remember here we have two vectors e plus and e minus. So we need to find out the angle between two vectors, and this is the angle theta. So this line and this line is parallel. So this is alternate angle. So this will be theta. Again, now This is also theta. So, and this is parallel. So this will be corresponding angle. This is corresponding angle. So this is also theta. So theta plus theta equal to 2 theta. We take 2 theta as angle between E plus and E minus. And then we apply the formula root under magnitude of E plus square plus magnitude of E minus square and plus E minus cos 2 theta. And you will calculate. Ultimately, lastly, you eliminate the cos theta and you will get the result same result you will obtain. So try in this method also. Next thing is, it is inferred that for very large distances, the magnitude of electric field at a point on the dipole axis is twice that of the magnitude of the electric field at a point on the equatorial plane. So the direction of electric field at points on the dipole axis is directed along the direction of dipole moment vector P, but at the point on the equatorial plane, it is directed opposite to the dipole moment vector, that is along minus P, that is opposite to that of dipole moment. So at a very large distance, the electric field due to dipole varies as inverse of cube of distance from the center of dipole. Note that for a point charge, the electric field varies as inverse of a square of distance. So this is the special case as it varies as an inverse of cube of distance. And due to point charge, it varies as inverse of a square of distance. So we can say that electric field due to point charge is spherically symmetrical, but in case of dipole, it is not spherically symmetrical. This implies that the electric field due to dipole at very large distance goes to zero faster than the electric field due to a point charge. If you take point charge Q plus or minus, and you take point charge plus Q and minus Q as a dipole, you will see that electric field will decrease with distance faster in case of dipole, but in case of point charge, it will be slower as one move away from the dipole or from the point charge. So in which case, electric field will be decreases faster in case of dipole, because electric field due to dipole varies inversely as a cube of distance. That's why it will decreases fast in comparison to that due to point charge, because in case of point charge, electric field varies inversely as a square of distance. So the reason for this behavior is that at a very large distance, the two charges appear to be close to each other and neutralize each other. As we move away and away from the dipole, from center of dipole, the separation between two charges will go on virtually vanishing, and the two charges will appear to be closer to one another, and that's why the system of two charges at very large distance will behave as a single charge. Okay, suppose the distance 2a, that is dipole length, approaches 0. That means if dipole length decreases to 0 approximately, and Q approaches to infinity and charge on dipole increases to infinity, such that the product of 2aq, that is dipole moment, equal to dipole length into charge. So dipole length is 0 and charge over dipole is infinite. So dipole moment is also infinite, because 0 into infinite becomes equal to 0. That is equal to finite. Remember, 0 into infinity equal to finite, equal to 0. 0 into infinity equal to 0, which is finite. So when charge on a dipole made to be infinite, while dipole length is made to be 0, in that case, dipole is called a point dipole. Remember, so far we have discussed dipole. Now here in this case, it is a point dipole. The point dipole means what? A dipole uh, have a zero dipole moment is a point dipole, because in the previous case I have told you even single point charge will behave as a dipole, but its dipole moment will be zero. So here also dipole moment is zero. That's why this is a point dipole. In which case, when dipole length is reduced to zero and charge on dipole is increased to infinite, therefore, product of dipole length, say 0, and magnitude of charge on dipole, say infinity, 0 and infinity, when multiplied together, we get 0 as a product. And a dipole with 0 dipole moment is called. Next, for such a point dipole, equation of electric field due to an electric dipole at a point along axis or axial line and equatorial line are exact and hold true for any. In this case, where dipole moment is 0, then electric field at axial line and at equatorial line will be same, no matters whether R is finite or infinite, whether R is negligibly greater than, whether R is much greater than A or not. In all the cases, electric field at equatorial line and axial line will be same. Okay, exact and hold true for anyone. In this case, electric field will be independent of. Now, next topic is, so far we have discussed electric dipole and electric field due to dipole. So when talking about electric field due to dipole, we have two cases. One is on axial line, other is on equatorial. And we have also seen that electric field at axial line is twice that on equatorial. So ratio of electric field due to dipole at axial line and due to dipole at equatorial line is just equal to 2:1. Now come when electric dipole is placed in an external electric field. Hello. When electric dipole is placed in external electric field, then it experiences a moment of force, because electric dipole consists of equal and opposite charges, system of equal and opposite charges. So when this system is placed in a uniform external electric field, then positive charge will be repelled in the direction of external electric field, while negative charge will be attracted in the direction opposite to the external electric field. So, in brief, try to understand. When electric dipole placed in an external electric field, then positive charge on dipole will experience a force in the direction of electric field. On the other hand, negative charge will experience an electrical force in the direction opposite to the electric field, because we know that electric force is equal to Q into E. So if Q is plus, electric force will be in the direction of electric field, and if Q is minus, electric force will be in the direction opposite to the electric. So consider an electric dipole of dipole moment P placed in a uniform electric field E, whose field lines are equally spaced, because we know that the uniform electric field will be represented pictorially by the parallel rays. So, whose field lines are equally spaced and points in the same direction. So, the charge Q, positive Q, will experience a force QE. Just I have discussed right now that E equal to Fe upon Q. Therefore, Fe equal to Q into E. So, if Q is positive, then positive charge plus Q will experience a force Q into E in the direction of electric field. And the charge, negative charge Q minus Q, will experience a force minus QE in the direction opposite to that. So, two equal and opposite forces experienced by the dipole, and this constitutes a couple of force that you would have gone through the in case of previous class, in class 11, in rotational dynamics, moment of force torque that you have. So this is couple of force, equal and opposite force, system of pair of equal and opposite force is called couple of force, and couple of force net linear effect due to couple of force is 0. But we cannot say that couple of force produce 0 rotational effect. So importance of couple of force is that although it does not produce any translational effect or linear effect, that means a couple of force cannot produce linear motion in an object, because couple of force is a pair of equal and opposite force, so net vector sum of these two pair of force is 0, and as these two pair of forces makes 0 net force, and hence produce no linear motion and linear effect on any object when it is applied on it. But it can produce a rotational effect, turning effect. So here is couple of force. So there is no linear force on net linear effect on the dipole. That means dipole will not accelerate or decelerate. It will remain stationary in the external electric field, but it can produce, couple of force can produce a rotational effect. Moment of force can be experienced here. So try to understand what will happen when dipole is placed in a uniform electric field. So here, since the external field is uniform, so total force acting on the dipole is 0. We can say total linear force is 0, because one force is plus Q into E and other force is minus Q into E, and magnitude of electric field everywhere is uniform. Therefore, sum of QE plus QE and minus QE is 0. So these two forces acting at different point will constitute a couple of force, and dipole will experience a turning effect, and this turning effect is known as moment of force, or we simply say torque, and this torque tends to rotate the dipole in the uniform electric field about the center of dipole, an axis perpendicular to the center of dipole. So this is the situation here. Look at this is this red line indicates uniform electric field, uniform because each line are equally spaced from each other, and this indicates that electric field is uniform, and this uniform electric field will have magnitude capital E. And you look at here, charge plus Q will experience a force in this direction, and on the other hand, charge, negative charge minus Q at A will experience a force minus QE in this direction. So a vector sum of these two force is 0. QE plus minus QE is 0. Therefore, no linear motion will be produced in the electric dipole. But what about rotational motion? Yes, there will be rotational motion, because a couple of force can produce rotational motion, turning effect. So this force tends to move in this direction, and this force tends to move in this direction. So moment of this force is clockwise, and moment of this force is also in clockwise. So the two forces are producing a torque in the same sense of direction clockwise. Therefore, the two moment of force can be added together to give net effective torque. So let us check it. And this is, remember, turning effect of couple of forces is measured as product of magnitude of one of the force and perpendicular distance between line of action of force. Remember, this is the line of action of force. This is line of action of force, and this is the line of action of force. And perpendicular distance between the two line of action of force is 2a sine theta. Why 2a? Because a and a, 2a is dipole length. So this acts as hypotenuse. Hypotenuse. So this perpendicular is expressed as 2a sine theta. So this 2a sine theta is nothing but what? Perpendicular distance between line of forces. Therefore, torque or moment of force is expressed as product of one of the force and perpendicular distance. So one of the force is QE. Magnitude of one of the force is QE, or mod of minus QE. So this is one of the force, and this is the perpendicular distance. So multiply together, what we get, that will give you torque. So let us here, the total torque on the dipole about the point O, about the point O. Look at. So this will produce torque clockwise, and this will also produce clockwise about this point. So the two torque produced by the two force about the same point are directed in the same direction. Therefore, these two torque will be added together to get net effective torque, and this is the result. Torque produced by negative force minus Q into E equal to what? Magnitude of one of the force, that is force into perpendicular distance. So this is the distance O to A. This is the O to A. And similarly, plus QE into O to B. So we write here, this is the total torque experience. Now take the things common together. Now torque is perpendicular to the plane of paper and is directed into the plane. Because this torque is clockwise, therefore it is directed into the plane. If it would have been anti-clockwise, then its direction would have been perpendicular and upward out of the paper. So try to understand. In this case, this torque will be directed into the page or into the plane of the figure. So here we have two vectors. One is this one and another is this one. So magnitude of two vectors can be obtained by applying formula root under a square plus b square plus 2ab. So in that case, so look at here. This is the result. So we get here QE डॉट 2a sin theta, जो कि मैंने पहले ही बताया था कि moment of force is expressed as product of magnitude of one of the force and perpendicular distance between line of action of force. This is the line of action of force, and magnitude of one of the force is QE. So दोनों का प्रोडक्ट ये हो गया. और अगर ऐसा होता है तो इसको क्या कहेंगे? देखिए, 2a into q को हम कहेंगे वेक्टर p, मोमेंट ऑफ फोर्स, और तब हमें मिलेगा p into e sin थीटा. और p into e sin थीटा को हम क्या लिख सकते हैं? ab sin थीटा इक्वल टू a क्रॉस b डिनोट करता है, तो p into e sin थीटा इक्वल टू क्या इंडिकेट करेगा? p क्रॉस e. So where theta is angle made by the vector p with e. Since p equal to 2aq, the torque is written in terms of the vector product as P cross E. This is the moment or torque experienced by the electric dipole when placed in a uniform external electric field. So magnitude of torque is P is sine theta and is maximum when theta is 90 degree. So this torque will be maximum when theta is 90 degree. And this torque tends to rotate the dipole and align it with the electric field. Once P is aligned with the electric field, the total torque on the dipole becomes zero. इसीलिए alignment से थोड़ा भी हम डायपोल को डिस्टर्ब करेंगे तो हमेशा वो चाहेगा कि वो अलाइन करना चाहेगा. जैसे ही अलाइन हो जाएगा उस समय नेट डायपोल जीरो हो जाएगा और उस समय इक्विलिब्रियम में होगा. So if the electric field is not uniform, अगर इलेक्ट्रिक फील्ड यूनिफॉर्म नहीं है, तब अगर डायपोल को उस नॉन यूनिफॉर्म इलेक्ट्रिक फील्ड में प्लेस कर देते हैं, तब क्या हो सकता है? तब क्या उसमें लीनियर एक्सेलरेशन हो सकता है? यस ऑफ कोर्स, क्योंकि जब इलेक्ट्रिक फील्ड नॉन यूनिफॉर्म है तब इक्वल एंड अपोजिट फोर्स नहीं होगा, तब फोर्सेस एक दूसरे से डिफरेंट होगा, तो नेट इफेक्ट ऑफ लीनियर फोर्स इज नॉन जीरो. जैसे लीनियर फोर्स नॉन जीरो हो गया तो इट कैन प्रोड्यूस एक्सेलरेशन एंड हेंस देयर विल बी translational motion produced in the dipole as well as rotational motion in the dipole. So when electric dipole is placed in non-uniform electric field, then electric dipole will have two kind of motion associated with it. One is rotational and other is translational. Okay, so try to understand. In addition to the torque, there will be net force acting on it. But in case of uniform electric field, net linear force was zero, but net rotational force or torque was non-zero. But here, net linear force will be non-zero and torque is already non-zero. So there will be two kind of motion, rotational as well as translational. So this is example of non-uniform electric field because electric field lines are not closely spaced or equally spaced together. Spacing between the two field lines varies place to place. That's why. So force at this location and force at this location will not be equal and opposite. That's why net sum of linear force will be non-zero and torque will be there. So object or electric dipole will experience two kinds of motion. अब example को समझा जाए. A small of hydrochloric, a sample of hydrochloric gas is placed in a uniform electric field. 3 into 10 to the power 4 Newton per coulomb. The dipole moment of each hydrochloric molecule is this much. This is P, capital P, factor. Calculate the maximum torque. The torque निकालने के लिए फॉर्मूला क्या अप्लाई कर देंगे? P क्रॉस E. P क्रॉस E. तो मैक्सिमम कहाँ पर होगा? जहाँ पर एंगल 90 डिग्री है. तो एंगल 90 डिग्री ले लेंगे तो मैक्सिमम निकल आएगा. सॉल्यूशन आपका ये है. माइक्रो ओवन में देखो टॉर्क का ये डायपोल मोमेंट का यूज करते हैं. कैसे? माइक्रो ओवन. Micro oven works on the principle of torque acting on an electric dipole. The food we consume has water molecules which are permanent electric dipole. हमने पहले भी डिस्कस किया था कि water molecule has permanent electric dipole. So oven produce microwaves that are oscillating electric field, electromagnetic field. हम जानते हैं कि सारे waves इलेक्ट्रोमैग्नेटिक है. माइक्रोवेव्स भी इलेक्ट्रोमैग्नेटिक वेव्स है और इलेक्ट्रोमैग्नेटिक वेव इज बेसिकली containing two kinds of field mutually perpendicular to each other, electric field and magnetic field. So this electric field will act on the dipole of water molecules and produce a torque on the water molecules. इसलिए it microwaves tends to rotate the water molecules because water molecule has non-zero dipole moment. Because water molecule has permanent dipole moment, it is a polar molecule. Therefore, electric field produces torque on this, and due to this torque on each of water molecule, the molecule rotate very fast and produce a thermal energy. As molecule rotate, so it has high rotational kinetic energy, and we know that anything, a hot body consists of energy in terms of kinetic energy. As kinetic energy ceases, it gets converted into